Hello everyone, welcome to Method. You are watching videos by Method. In this particular video, I am going to show a very interesting geometric problem from AIME 2021. And here is the view of the problem. Now let omega 1 be a circle with radius 961 and omega 2 be a circle with radius 625, and let omega be a circle that touching both omega 1 and omega 2 externally. Now if omega 1 and omega 2 intersect each other at A, then the line joining of AB intersect omega at P and Q. Now assume that O1, O2 and O are centers of omega 1, omega 2 and omega respectively, and it's given that the PQ, I mean the minor arc of PQ, makes 120 degree with the center of omega, which means this angle right here is 120 degree. In this problem, it's asked to find out the length of O1, O2, or more precisely the distance between the centers of omega 1 and omega 2. Now I should draw a triangle that consists O1, O2 and O as its vertices. Now see that AB is the radial axis of omega 1 and omega 2. So we can say that O1, O2 is perpendicular to AB. Now let the radius of omega 1 is R1 and radius of omega 2 is R2 and the radius of omega is capital R. Then we can say that O1O is R1 plus capital R and OO2 is R2 plus R. Now we should only focus in the triangle O1, O2, O. On that purpose, I just took this diagram right here. Now let is the intersection point of O1, O2 and AB. And now I should make a construction that I drop a perpendicular from O to O1, O2, and let the feet of the perpendicular is T. And in this diagram, see that the distance ST is actually the perpendicular distance of PQ from point O. Now it's pretty easy to see that ST can be written as OQ cos 60 degree, which is exactly equal to OQ by 2, which means capital R by 2. Now see that S is on the radial axis of omega 1 and omega 2. So we can write that power of S with respect to the circle omega 1 and power of S with respect to the circle omega 2 is same. So we can write that O1A square minus R1 square equal to O2A square minus R2 square. By rearranging, we get O1A square minus O2A square is equal to R1 square minus R2 square. So let's proceed further. Now if you notice that O to T, this distance is equal to O2S minus ST, and the distance O1T is equal to O1S plus TS. I think this is pretty clear. Now in this blue triangle, using Pythagoras theorem, we can say that R2 plus R whole square equal to O2T square plus OT square. Let's mark this equation as star. Now if we use Pythagoras theorem once again in this yellow triangle, then we must get that R1 plus capital R square equal to O1T square plus OT square. Let's say this is the equation number double star. Now using these two equations, we can write that OT square equal to R plus R2 square minus O2T square, which is again equal to r plus r1 square minus o1t square. So we can write that r plus r2 square minus r plus r1 square equal to o2t square minus o1t square equal to o2s minus tss whole square minus o1s plus tss whole square. Why? Because we have previously shown the values of o2t and o1t in terms of o2s minus ts and etc. Now if we expand the right side, then we should get this thing right here. Now you can see that r should cancel out. Now we should expand the right side to get this following thing, as you can see. Now in this case you can see that ts square should cancel out. So finally, after rearranging, we get that r1 square minus r2 square plus 2 into r1 minus r2 equal to o1 a square minus o2 a square plus 2 st into o1s plus o2s. Now each of the terms here, here and here is previously described. Now the term o1a square minus o2a square is equal to r1 square minus r2 square, and st equal to r by 2, and o1s plus o2s is equal to the distance o1 o2. So r1 square minus r2 square should cancel out. Now we can write that 2 into r by 2 into o1 o2 equal to 2 into r into r1 minus r2. So finally we get o1 o2 equal to 2 r1 minus r2. From here the rest is very easy, so we can get that our desired result as following, that 2 into r1 minus r2 is given by 672. So this is our final answer. Thanks for watching this video. Stay tuned for more videos.